Hey, what's up, party people? It's Mr. Tate here. I'm actually in a hotel room getting ready for a wedding, but I wanted to give you guys a quick introduction and understanding of the force calculations for our egg drop project. So this is going to be part of your assignment for today. Okay, so these are the equations that I have up on the board currently. Okay, so it'll be all on paper, so I'm gonna have to go back and forth, and I apologize for that, but I promise I will do my best to explain it the best way I can. So here is what we have. Okay, so you'll notice up here we've got three main equations, and these are equations that I still have written up on the board, even though I'm not there today. Okay, so we have v squared equal to v sub 0 plus 2a parentheses v minus v0. Okay, the next one is an acceleration equation. So we have v0 minus v divided by t. And lastly, we have Newton's second law, which is F is equal to ma. So force is equal to mass times acceleration. So guys, basically what we have here is we have an object. So it says, hi, I'm an object. We have an object that's falling in free fall. Okay. The way that this works is there's one force that is acting upon this object, and that's gravity. We know that gravity is equal to negative 9.8 meters per second squared. Okay, so that's how it's always been, it's always will be. So this object is dropping at an acceleration of negative 9.8 meters per second squared. Okay, so what we need to find out though is we need to find out how fast is this object moving whenever it hits the ground. Okay, we want to find out how fast is the object moving whenever it gets to this point right here. Okay, so a couple things that we need to know. Okay, we need to know the mass of the object, the time that it took that was in the air, the height it was dropped from. Those are the three things that we need to know. And then we've got some helpful conversions down here. Okay, it says 1 foot is equal to 12 inches. 1 foot is equal to 0.305 meters. And then this tells us all the different things that the different portions of the equations are. The V stands for the impact velocity. The V0 stands for initial velocity. Okay, the acceleration is equal to A. The Y is equal to the final destination. And then the y sub 0 is equal to the initial destination. So on our guy up here, I will label each one of these. Okay, so a couple things to talk about before we get into this. So these equations up here do look a little scary. However, we already know what a lot of these things are just by givens or by just simple scientific theory. So I know up here, okay, a couple different things. All right, so let's look at V sub naught first. Okay, V sub naught we see is how fast the object is moving whenever it is right here. So basically thinking about you are currently holding your egg drop project up in the air, up at that string. How fast is it moving? It's not moving at all, right? So it is actually moving. So V sub naught or V sub 0 is equal to 0 and will always be equal to 0. Okay. Let's think about A for a second. Okay, A right here. So the acceleration of that object. Okay, I told you guys earlier that what? Gravity is the only thing that is acting upon this object at a given time. So we know that it's going to be accelerating always at negative 9.8 meters per second squared. So A is always going to be negative 9.8. All right, so pretty solid there. All right, let's look down here. Okay, Y, my final distance. Okay, my final distance. So I'm starting at a height up here, which we'll talk about this y sub 0 here in a little bit. But this y down here, this final distance, all right, so I start up here, I drop all the way down to the ground. I'm measuring basically in height, okay, initial height and final height. Okay, so what is my height right here going to be if it's on the ground? Also 0, okay? So y is also always going to be 0. Okay. 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 So the main things, we're going to be finding v. Okay. The last thing we need to know is this y sub 0, which is going to be our typical height. Okay. The height that we dropped it from. We know that the string in my classroom is currently at y is equal to 7.5 feet. Okay, 7.5 feet. Okay, but we know that in physics and that kind of stuff, we need to convert this to what? We need to convert it to meters. Okay, so in order to get meters, we've got 7.5 feet here. In order to get that to meters, we need to multiply by our conversion factor down here. So we've got 1 foot is equal to 0.305 meters. Okay, so I've got 7.5 feet. So for every foot, I get 0.305 meters. Okay, so basically what I need to do is I need to multiply this 7.5 times 0.305. Okay, 7.5 times 0.305. Then I'll get my measurement that I need in meters. Plug this into the calculator. 7.5 times 0.305. I'm going to get 2.29. 2.29. You can see that in the calculator. Always round to the nearest to the second decimal place. Okay. See that 7 is greater than 5, so I'm going to round up to 2.29 meters. Okay. So I know that I am dropping this object at 2.29 meters above the ground. So this is 2.29 meters. All right. So I've got just about everything I need to do this top equation right here. Okay, so I've got v squared equal to v sub naught plus 2a y minus y sub naught. Okay, so we'll get started. I'm gonna write everything down. Y minus y sub naught. Okay, got everything written down right here. All right, so good thing is I already know what this value is. V sub naught is 0. I know what this value is. A is equal to negative 9.8. And I know what y is, which is equal to 0. I'm going to plug those guys in real quick. 0 plus 2 times 9.8. 0 minus y sub naught. Okay, I just plugged in my values for v sub naught, a, and y. Okay, pretty straightforward. The last thing I need is my y sub naught value. So it's y sub 0. So I'm going to plug in what I found. I found that y is equal to 2.29 meters. So I'm going to plug that into right here. All right. So now I've got everything plugged in here. So I've got my v sub naught value, which is 0. I've got my a value in, which is negative 9.8. I'm not sure if I talked about this. This is just the number 2. Okay, it's just the constant that is in there every time. Okay, negative 9.8, which is my a value, my y value, which is 0, and my y sub 0 value, which is 2.29. Okay, now all I'm going to do is I'm just going to plug everything into the calculator. The important thing here is to remember your parentheses. So I've got 0 plus 2 times negative 9.8 times 0 minus 2.29. All right, so I'm going to get a value 44.88. We'll just say 88, since the 4 is less than a 5 at the end. Okay, so this is equal to 44.88. All right, so I get v squared equal to 44.88. Well, okay, here's the problem though. I need v. I'm looking for v, this impact velocity here, not v squared. So what do I need to do? Always do the opposite. If I'm squaring something, the opposite of that is to square root. Very nice, everybody. It's like you're almost here with me. So I'm going to take the square root of both sides here. Square root. And I'm going to get, we'll just round this one to 1 decimal spot. So if I get 6.6999995, I'm just going to round this up to 6.7. So my velocity is now 6.7 meters per second. Okay, so basically what I know now is that as I drop this, it is moving at 6.7 meters per second whenever it hits the ground right here. Okay, so really good stuff. All right. All right, so that's the first portion of this section. So I have conquered this equation so far. So now let's move over to, now we're going to calculate acceleration. Okay, you might be like, yo, Mr. Tate, we already know the acceleration, it's gravity. Okay, so we actually need to know how long gravity has been acting on an object as it's been falling. So the cool thing about gravity is that it accelerates at 9.8 meters per second. Okay, so it's getting faster and faster and faster. So for instance, it'd be moving 19.6 after 2 seconds. It'd be moving over 27 after 3 seconds, 27 meters per second after 3 seconds. So some cool stuff in there. So we're going to calculate this value. So we have v sub 0 minus v, which we just calculated, divided by time in the air. Okay, so we will get that. All right, so on the board, yesterday whenever I dropped the egg in class, I believe that our time in air was 0.72 and our mass was 58 grams. Okay, so up here, okay, it was 58 grams for the mass and it was 0.72 seconds that it was in the air. Okay, so I'm going to write the second part of this equation here. I've got v sub 0 minus v over time right here. So I've got a is equal to v sub 0 minus v over time. Okay. Good thing is, I already know what v sub 0 is. It's 0. I know what v is now. It's 6.7. And I know what time is. It is 0.72 from my trial that I did. Okay. I'm just going to plug all these values into our equation. So I've got 0 minus 6.7 divided by 0.72. Okay. So the equation should look something like this. Okay, right here. All right, so all I got to do now is I'm just going to plug this into the calculator. So I'm going to do 0 minus 6.7 divided by 0.72. And I'm going to get negative 9.31. We'll say negative 9.31. Okay, so the acceleration is equal to negative 9.31 meters per second squared. Okay. I've got my A value now. Great job, everybody. So conquered step number 1, conquered step number 2. Let's move on to step number 3, which is finding the actual force. Okay, so force is equal to mass times acceleration. Okay, so we know our mass, which is 58 grams, and we know our acceleration, which we just calculated here at negative 9.31 meters per second squared. So all we got to do now is plug it in. Put my equation right here. Force is equal to mass times acceleration. Just plug in my values. I've got 58 for my mass. I've got negative 9.31 for my acceleration. 58 times negative 9.31. I get negative 539.98. Okay, these are measured in newtons. Okay, Isaac Newton got so cocky about all of these laws, he decided to name a unit after himself. So this is negative 539.98 newtons. Okay, so you might be asking, Mr. Tate, why is it negative? Okay, that's because it's a downward force. It's a downward force, so it's coming down on the ground. Okay, so that's why it's negative. Okay, to kind of put it in perspective for you guys, 1 Newton is about the how all the pressure that an apple puts on your hand whenever it's sitting on it. Okay, so if you can think about it, that egg is hitting the ground pretty dang hard. So in retrospect, this is the force that you need to compensate for with your capsule design. Okay, so you're hitting, this egg is hitting the ground hard. So your design needs to be able to protect it with everything that it can. Okay, so that's just about everything. So basically, we calculated the impact velocity with this equation right here. Okay, we calculated acceleration with this equation right here. We calculated force with our final equation. Remember that initial velocity is always 0, a is always 9.8, negative 9.8 meters per second, and y right here is always 0 as well. Okay, it's never moving whenever we're initially dropping it, so our acceleration, initial acceleration is 0. Okay, the final height or the final destination is always going to be 0, and then the acceleration it's following at is going to be negative 9.8 for this equation right here. Then we'll go in and we'll actually calculate what the acceleration actually is. Then we'll calculate our force. Okay, remember these conversions over here, which are very helpful. And these are the three things that you need. What is the mass of the object? What is the time in the air? And what is the height that it fell from? Okay, so if you guys get all of that, you guys will be golden. Okay, you guys are going to have an assignment today that's talking about finding the conversions for all of the different pieces. So hope you guys enjoy. Shoot me an email if you guys have any questions, and I will see you guys on Monday.